Thank you to the session chairs for their invitation and the opportunity to present at this year's annual meeting. Also, thank you to the conference attendees for your participation. My name is Ronald Hodge. I'm a senior manager with the Office of Research, Applied Analytics and Statistics within the Internal Revenue Service. My organization is responsible for providing strategic, analytical, and technology services in the support of more effective and efficient tax administration. And we do so in partnership with internal stakeholders and external stakeholders. In my role, I'm responsible for the operation and maintenance of the IRS's Enforcement Revenue Information System, a system that tracks taxpayer level revenues across IRS enforcement activities. My team not only operates and maintains that system, we also have primary responsibility for reporting data from the system as well. And we also conduct a series of analyses that use enforcement revenue data as a focal point. Outside of enforcement revenue-based initiatives, I also manage analytical initiatives supporting other IRS divisions in other contexts. Those initiatives focus on applying machine learning, deep learning, natural language processing, image processing to address a variety of different business problems. My tutorial will focus on some context setting about tax administration and aspects of IRS operations while connecting some of those operations to analytics. I will also detail a few analytical efforts that are going to be a combination of work that I lead, but also a combination, also includes some work led by my colleagues. This tutorial is meant to highlight key aspects of tax administration, both generally and at the IRS. My hope is that at the conclusion of this tutorial, the attendees will better understand the analytical opportunities that modern tax administration provides. On to the standard disclaimer. The views expressed are those of my co-authors and myself and do not represent the official position of the Internal Revenue Service. So what is the tax administrator's mission? So to better highlight the analytical opportunities that exist within tax administration, I first want to detail my interpretation of the tax administrator's mission based on my experience working at the IRS. From my perspective, tax administration is a combination of both service and enforcement. Activities that assist the taxpayers in meeting their filing, reporting, and payment obligations would be considered the tax administrator's service component. This could be website content or web applications that focus on addressing a taxpayer's specific question, like tracking of an anticipated refund. It could also be call centers with either automated or live assisters to assist taxpayers with establishing a payment plan to pay down an existing balance. Scenarios where either the filing, reporting, or payment compliance obligations are not met, the tax administrator, as determined by law and within their designated authority, may choose to enforce compliance. For example, if a taxpayer is perceived to have been inaccurately reported something on their tax return, the tax administrator may request additional records and documentation from the taxpayer so that they can substantiate the claim that was made on the tax filing. Another situation is if a taxpayer has been determined to not have paid the full amount of tax owed by a specified due date, the tax administrator may move to collect any of the outstanding balance. Oftentimes, discrepancies or disagreements arise between the tax administrator and the taxpayer. So there will also exist a function that could help settle disagreements between both parties, and that would be more like an appeals function that exists within the IRS. So on to the IRS. At the federal level in the United States, the Internal Revenue Service, or IRS, is the tax administrator. And as such, the IRS has the obligation to administer and enforce the Internal Revenue Code, or the IRC, which is enacted by the United States Congress. So just to differentiate the two, the IRS administers and enforces the tax law, Congress writes the tax law. The IRS is also the tax collector at the federal level. So taxes collected through the voluntary compliance of taxpayers or through enforced compliance are in the purview of the IRS. The IRS is organized into 4 primary business operating divisions, and those divisions are organized around customers with a similar set of needs. There's the wage and investment division, and they're responsible for administering the tax law governing individuals who earn income through wages. So this would be people who are, either salaried employees or hourly employees, and their income is typically reported on Form W-2. These taxpayers also can generate income from the sales of stocks. So that's the investment piece on wage and investment. There's also the large business and international division, and their customers are corporations and partnerships with assets of $10 million and up. And it's also in LB&I, or the large business and international division, they also have customers who are individuals and businesses that have financial interests outside of the United States with potential US tax implications. Onto the small business and self-employed division, their customers are also corporations and partnerships with assets under $10 million. So it's a complement of the large business and international division's corporation and partnership customer base. But within the small business and self-employed division, they also have taxpayers who are generating income from farms, rental properties, and they also, contain customers who have small businesses with or without employees. There's also the tax exempt and government entities division. Their customers are taxpayers that are exempt from income tax. Think about those taxpayers are, those entities are charities, private foundations. Also within tax exempt and government entities, they have customers who are pension funds, retirement plans, and also federal, state, and local government. The IRS also has an independent Office of Appeals that looks to resolve tax controversies in a manner that is both fair and impartial to the taxpayer and the government, and they settle disputes between taxpayers and the compliance functions that address, payment, reporting, and filing compliance issues within the IRS. The IRS also has a criminal investigation division that investigates violations of the Internal Revenue Code that are criminal in nature, and they also pursue any of those related financial crimes. So taxpayers can differ in size, the method by which they generate income, the tax code sections that govern their filing, reporting, and payment obligations. And this variability among taxpayers provides a lot of interesting challenges and opportunities to make tax administration more effective and efficient. So on to tax return processing. So as we build towards more specific analytical opportunities and use cases, I want to start to illustrate the size and scope of certain components of the IRS's mission over the course of the next several slides. So the diversity among taxpayers is not only reflected in the organizational structure that I covered in the previous slide, but it's also reflected in the types of tax returns that the IRS processes. Some taxpayers file electronically. So think about, individual taxpayers filing their tax return using something like TurboTax. And their filing data can be made accessible relatively quickly for analytics. However, some taxpayers prefer and can file on paper, and then they mail their tax returns into an IRS facility. And that paper file data can be made available, but first must be imaged or converted to some type of machine readable format. And then the information is then extracted from the images or the machine readable file before that data is suitable for analytical uses. In a recent fiscal year, the IRS processed over 250 million tax returns. And tax return data is, and just data in general, is going to be central to what we might be able to pursue in terms of analytical opportunities within tax administration. So within our particular data and analytics environment at the IRS, in some cases, we have well over 2 decades worth of tax return information. And it's typically for core populations like individual taxpayers or corporations. And given the mission of our agency, it's very important for us to know with a great deal of specificity: who filed what tax return, when did they file it, what did they report on that tax return, and how much tax was paid. So an added benefit of our data is that there exists opportunities to connect a single taxpayer's return filings together. So you can develop a bit of a time series of a tax filing for an individual taxpayer, and we track taxpayers through the system with a taxpayer identification number. That identifier is also found in other operational systems. So outside of tax return data, we have the opportunity to use other operational systems data as well as tax return data and create really rich data sets with a lot of information to support some of the analytical work that we do. So if a taxpayer identification number allows us to associate data to a single taxpayer, we also have opportunities to associate taxpayers with one another. So for example, a taxpayer and a set of taxpayers may generate income from a partnership that they're both involved in. Or taxpayers may get their returns prepared by the same tax preparer. So there exists opportunities for us to group sets of taxpayers together, and through other associations, and these other associations can be used to construct taxpayer networks or taxpayer graphs. So as I mentioned before, one of the primary responsibilities of the IRS is to collect taxes. So through a largely voluntarily compliant taxpayer base, the IRS collects trillions of dollars in taxes each year. Some of these components are going to be collected from, just general return filings or, taxes that have been withheld over the course of a year. But there are also situations where these revenues are going to be generated from IRS enforcement activities. And these enforcement revenues will also include any applicable penalties and interest. So from a data standpoint, we have granular data on specific taxpayers and the taxpayers they pay and the taxes that they paid. So whether taxpayers have a certain amount withheld over the course of the year, we'd be able to know that. If a taxpayer wound up in an enforcement function and was shown to owe additional tax penalties or interest, we'd know that as well. So with the tax return data, tax revenues collected, at a really granular level, hopefully you can start to visualize some of the opportunities that may exist. So one that comes to mind is there's something where tax return data is in our set of predictive variables, and revenue would be an outcome variable that we'd be interested in developing some predictions around or forecasts around. So there's a flip side to the tax collection coin, and that's issuing refunds. So oftentimes taxpayers over the course of the year, they may have had too much tax withheld, or at filing time, there may be a series of tax credits that the taxpayer is eligible for that have lowered their tax liability so much so that they are issued a refund. So the goal of the IRS is to make sure taxpayers pay what they owe, and if they pay too much, a refund will be issued. Just as if the IRS, if you haven't paid enough, the IRS will try to move to collect some of that outstanding debt. So the IRS not only collects revenues, but returns money to taxpayers on overpaid accounts. There's another opportunity for the IRS to distribute money outside of the core refund issuance process. The IRS also distributes economic stimulus payments. So this was done during the Great Recession in 2008. And this has been done fairly recently for the COVID-19 pandemic. And this is those stimulus payments were the economic impact payment. And analyses have been done on who receives refunds, the method by which they receive them, whether it's folks who want to check or who have an electronic funds transfer. And with economic stimulus payments, they actually offer a lot of interesting policy-based analysis about the immediate and long-lasting impacts of stimulus programs that are administered through the IRS. So one thing to be mindful of is that whenever monies are being dispensed and being dispensed at such large volumes, there tend to be bad actors looking to acquire these monies through fraudulent means. So another opportunity that exists is for the IRS to develop and implement strategies, both from an operational standpoint and an analytical standpoint, to protect those revenues from going out and keep these bad actors from receiving payments that they are not legally entitled to. On to taxpayer service. So taxpayer service also presents a lot of interesting opportunities. Within the IRS, there are multiple service channels. There are web, phone, in-person, and even a mechanism for taxpayers to submit correspondence. So understanding taxpayer preferences, taxpayer needs, that's going to go a long way in helping us and helping IRS operations with things like demand forecasting and capacity planning. There are also opportunities within, the outreach space for us to connect with taxpayers and make them aware of channels that may meet their needs and may do so more efficiently. For example, one is, we've done some behavioral type analyses to determine which taxpayers may respond to an informational notice, making them aware that they can establish a payment agreement via a web application versus, going to the phones or, trying to set up an appointment at a walk-in site. We also are using available customer service data from across channels. And, we hope to analyze that information to better describe the types of interactions that we're seeing and, how the types of interactions that we're seeing over time. We've also moved to use notes that are taken by customer service representatives or accounts management personnel during a taxpayer interaction. And we're starting to, categorize those interactions using natural language processing techniques. So we've done things in the space like topic modeling of some of the text that we've seen from those notes. Within IRS, there also exists quality assurance processes where a sample is taken of a set of taxpayer interactions. And from those samples, there are a lot of open-ended responses where folks are detailing what happened on that particular interaction, what was the taxpayer's problem, what was the recommended resolution. And what we're starting to do is comb through some of those samples and try to find out what opportunities may exist for us to develop and deploy new content on irs.gov. So on to enforcement activities. So this is not necessarily the most beloved part of tax administration, but enforcement is key to ensuring voluntary compliance. And it also provides a lot of opportunities for analytics. There are different types of non-compliance that must be managed, and this maps to a lot of those, maps to the filing, payment, and reporting compliance obligations that I mentioned earlier. So non-compliance management is occurring across all three of those dimensions, both filing, reporting, and payment. But also we're managing this non-compliance both in person and using remote methods as well. So, with that, we also have the diverse set of taxpayers and large volumes that we talked about a little bit earlier. So they're near endless amounts of taxpayer, non-compliance issue, enforcement treatment combinations that we might be able to deploy. However, it's not necessary or practical to pursue all of these combinations. It's unnecessary mainly because we have a largely compliant taxpayer base, and most taxpayers' interaction with the IRS is only when they file their tax return, and that's it. And then they come back again and file another tax return the following year. We don't have to pursue all of these different enforcement combinations either, because we just don't have the resources to do it. So without the ability to pursue all suspected non-compliance, we have a challenge, and that is how do we identify the cases with the most non-compliance risk? And from there, how do we identify the best treatment type to address that non-compliance based on the taxpayer's circumstances and also under a fixed resource capacity? So IRS enforcement is what I consider to be a very large, interconnected, interdependent optimization problem, but under uncertainty, mainly because taxpayer and IRS states are changing each and every day. So speaking of resources, staffing has been trending downward for several years now, but the mission for the IRS remains the same. So in a very diverse and dynamic environment, this is where we really see a lot of analytical opportunities for us to help make tax administration a lot more effective and efficient. So this slide is intended to just showcase some of the opportunities that we have, but also showcase some of the areas that we're currently working in. So again, with the large, diverse customer base that we have, data that's both available and granular, and a lot of challenging business problems that I mentioned earlier, there are a wide range of opportunities to use analytics at the IRS today. Some of those opportunities I've alluded to in earlier slides, and some I'll discuss further in subsequent slides. But my hope is that you're starting to see what opportunities may exist for an analytics practitioner. So given the opportunities that we have, it shouldn't be surprising that we have a presence in a lot of these different practice areas, from machine learning to graph mining. And the next several slides will detail more specifics about some of these practice areas and potential use cases. So in this particular use case, what we're looking for in terms of the business problem that we're trying to address is, again, we have situations where we have a lot of taxpayers, and we can only follow up with a segment of those taxpayers. So one of the things that we want to do is, well, how can we use analytics to segment the population, identify taxpayers who may be, anomalous in some sort of way. So this particular use case is focused on the use of recommender systems, and in an effort to identify anomalous taxpayers. So in product recommender systems, you would have a list of users and products that they've rated, watched, or purchased. And these products could be songs, movies, or books. In tax administration, we have an analog where the users are instead tax returns, and the products are instead reported line items on that tax return. So in the product user example, user information, for instance, if they watched the show or purchased the product, that can be represented by an n-dimensional vector that would detail whether they purchased the product or not. With M users, this creates an M by N product user matrix, but this matrix will be sparse because not all users would have purchased or purchased all products or watched every single show. So the goal of product recommendation is to fill in the missing values of that sparse matrix. In tax administration, we can also construct a matrix of M tax returns with N line items, and use the same sparse data algorithms used in product recommendation to forecast and estimate all line item values. So again, the sparsity occurs within the tax administration or tax return example because not all taxpayers are going to complete every line on a tax return. So what we have there is two totally different domains, but they can share a common analytical framework. So once we're able to develop a recommender-based approach, and we're able to provide estimates at model-generated tax return line item estimates, that in isolation might not be enough signal for decision-making. However, we can use the as-reported line items to put the model-generated line item values into some type of context. So given that the model is designed to learn relationships based on the training data that it saw, the hypothesis is that if the as-reported line items value, if the as-reported line items value differs sufficiently from the model-generated line item value, that may indicate some sort of anomaly. So for a given tax return, we'd be able to determine, well, how different is, or how wide is the gap between the as-reported and the model-generated line item value. So how anomalous is a set of tax return line items. We then can aggregate the line item level anomalies to establish anomalous tax returns. So using the recommended systems-based methodology we've done so far is we built models capable of identifying returns with potential compliance risks. And we've actually looked at some historical data and performed some back testing on several years of data of closed cases that have actually gone through IRS enforcement action, and we use that information to help us assess our model performance. We've also taken the cases selected by our model and had them undergo manual review by subject matter experts, mainly to determine whether or not there's utility in our case level scoring, line items level scoring, and the ability for the model to recognize potential compliance risk. Because something being anomalous in isolation is not necessarily a guaranteed compliance risk issue. So having these cases, these tax returns undergo manual review is helping us try to figure out where some of the potential compliance risks may be. So as applied researchers in our organization, we're going to attempt several approaches to address the same type of issue. So one of the things that we wanted to do was, we've already started the recommender-based approach, and we've seen some great success there. But what we wanted to do is start to move into, other, types of analytical opportunities. So with the data that we had from the recommender project, we wanted to see if we can apply deep learning to line item level anomaly detection. So for this, we're actually using autoencoders. So a lot of the same principles in terms of, establishing some baseline for normal and trying to figure out what may be anomalous. A lot of that is present in trying to use autoencoders, because autoencoders are designed to learn a compression function that maps the input data to a lower dimensional representation. And then at the same time, it's trying to learn a decompression function that takes the compressed representation of that input and reconstructs the original output, albeit at some degraded level. So again, the autoencoders are designed to learn from the examples that they're given, and they won't be as successful at reconstruction if new samples that it sees are substantively different than the data that was used to train on. So very much like we were experiencing with the recommender-based example. And we can use that to our benefit. So our hypothesis going in is that the reconstruction error is going to be small if it's a more normal tax return data sample, and it's going to be larger if it's anomalous. So what we can do is actually use the reconstruction error as a way to score potential anomalies. And we can use those scores to flag potentially anomalous tax returns, just as we did in the recommender use case that I mentioned previously. Machine learning for revenue estimation. So as I mentioned in the beginning, I'm responsible for a system that tracks enforcement revenues at the taxpayer level. And each year, millions of taxpayers have accounts that are going to enter some type of account receivable status. So they're going to owe the IRS and the Treasury money. So with that, for our accounts receivable, there's a lot of different operations and programs focused on helping taxpayers pay any balances that they owe. And in one of those programs, the taxpayer actually applies to be in the program. The IRS is going to correspond with that taxpayer to request documentation about the income that they're receiving, any existing liabilities that they have, both at the IRS and outside of that, and any available assets. And they're going to use all of that information to determine the taxpayer's ability to pay and what amount the taxpayer might be able to pay over a specified time period based on their circumstances. And since this data is within the system that I manage, my team and I propose integrating data from our system, so bringing in that enforcement revenue data with data from this payment program's operational system to see if we could develop a model to estimate revenues for potential program participants. So outside of just the operational program data and the revenue data from our information from our system, we also incorporated tax return data and prior taxpayer history to construct our modeling data set. And one of the things that we wanted to do in terms of developing a model is focus on a set of predictors that are going to be available when the case arrives to the program, so we have the maximum opportunity to have impact on the operations decision-making process. So we don't want information that's gonna, in terms of our model, that happens after it arrives to the program, because that limits our ability to actually impact decision-making in subsequent periods. So one of the things that we found out in developing and running these models is that our model actually performs better with certain case dispositions rather than others. And with that, one of the things that we now want to focus on is because we don't have as even model performance across dispositions is, well, we could probably make an attempt at modeling, developing models focused on predicting case disposition, and then we compare that with our existing revenue estimation model. And we'll use that to support decision making going forward. So one additional aspect of this program is that the cases are worked in first in, first out order. So according to a FIFO service discipline, and all of the cases must be worked. So one of the things that we started to talk about within our group is whether or not we can use the revenue estimation model to help develop a case prioritization score. And the goal there is maybe there's an opportunity to help us alter the service discipline and maybe increase throughput through the system over a specified time period. So, a lot more work to be done in this space, but we're off to, a really good start, and we have a really engaged customer for this work. So on to graph mining and deep learning, opportunities that graphs may allow for us to explore. So one quick note about taxpayers. Earlier I mentioned partnerships. Partnerships are pass-through entities, and this is situations where income from that particular entity is passed through to its owners. So partnerships, trusts, and S corporations are examples of pass-through entities. And the owners of these pass-through entities, they can be individual taxpayers, they can be corporations, and they can be other business entities such as tax-exempt organizations. So pass-through entities can form multi-tiered organizational structures, and they can be represented as a property graph. So the challenge that we wanted to explore was, can we identify frequently occurring substructures or subgraphs that are occurring within these multi-tiered structures? So using the graph-based substructure pattern mining algorithm GSPAN, we detect frequently occurring repetitive subgraphs. One quick note about pruning the overall population is partnerships that had too few entities, they were discarded because they just lacked the complexity that we would typically be interested in. And then some partnerships just have far too many entities, and they were discarded because they're computationally, due to computational concerns. So, this is a very challenging problem with a lot of different combinations. So, eliminating some of those more complex entities will actually allow us to run the algorithm and get some results out. So using GSPAN, what we were able to do is, one, identify a set of frequently occurring substructures, but we're able to now do this over time to see what trends may occur. Is it different set of substructures appearing over time, and does this differ based on whether the pass-through entity is a partnership, a trust, or an S corporation. So outside of that, one of the things that we wanted to do was take those frequently occurring subgraphs and transform them to multi-dimensional vectors using graph embeddings. So a strength of graph embeddings is that they hopefully retain information about the graph, the topology of the graph, and some of the node and edge properties. And once the graph has been converted to a vector or set of vectors, other machine learning methods can be used. So, machine learning methods focused on classification, clustering, or anomaly detection, they come into play. And as such, one of those methods that we use is it's more of a dimensionality reduction technique, but TSNE, what we can do is we can start to view the graph embeddings in 2 dimensions. And if you look at the scatter plot on the bottom left or the right side, the one with the green and the bright green and the blue, you can see that some of the similar structures are actually clustering together. And we've used the graph embeddings in another scenario where we use an isolation forest algorithm to see if we can detect anomalous or abnormal substructures. So on to natural language processing and opportunities in the risk identification space. So oftentimes in IRS, there's going to be a document or set of documents with a lot of pages, and typically these documents are going to require some type of manual review. So in this particular use case, tax exempt and government entities, they have an operation where they're receiving referrals, thousands of referrals in any given year, and the referrals are meant to highlight potentially suspicious activity in the tax exempt space. But as these referrals are undergoing manual review, only a fraction of them have been considered as being high priority. So I think the numbers are around 10%. So the current process is again very manual, very involved, and they're processing these things in a first in, first out order. And basically, this treats every single referral as being of equivalent priority when they know that there exists a population, albeit small, that are going to be high priority. So the goal is to how can we better highlight the high priority referrals. So the goal for this particular effort is to use deep learning and natural language processing to help reduce the level of manual effort required to triage some of these incoming referrals. So raw text, for a lot of different NLP tasks, you can't really work with it. So the first step is convert the text into a vector of numbers. There are a lot of simple techniques out here that are typically based on frequency of the word appearing. So the bag of words model, and it's just counts of words or sequences of words in the text. And those type of techniques where it's just counting the word or count sets of words, it doesn't take into context the context of the word. So, but embeddings, they'll help us preserve some of that context, albeit in a lower dimension. And just as we did in the graph embedding example, once we had those word embeddings for a set of documents, we now can access some of those more traditional machine learning methods. So for this use case, we were focused on classification, and we developed a series of classification models that would label or classify a document as being low priority, medium priority, or high priority. So this is going to meet the objectives of this referral process, and using analytics to highlight the high priority cases and offer some efficiency gains to the process and reduce some of the manual effort required there. So again, as I mentioned in the previous example, there are opportunities where there's a document with a lot of pages and we're only interested in a subset of that information, but we don't want to expend too much effort manually combing through pages, extracting information out. So what we've been focused on fairly recently is, well, how can we use image processing, deep learning, computer vision, and object detection to help with that particular task? So how can we use these techniques and a little bit of natural language processing as well to help us find the information that we're interested in a large collection of documents? So one of those areas is where we have some ongoing work is in the appeal space, and we're looking to apply deep learning and natural language processing to appeals determination documents for insight generation. So just a bit of context. As appeals within IRS, as they disposition a unit of work, they summarize the issues that were involved in the case and their recommended resolutions in a complex, non-standard document. So it's non-standard because there's not a fixed template or file format that the document's contents can be entered into, and it's complex because these documents have a lot of different components. So there's a narrative component, and the narratives, they can provide background information, summary information, but also information about appeals rationale for making a particular determination. Another component of these documents is there's a table that's contained within the document, and this table has not only well, a listing of the issues that are being appealed, but also some of the dollar values that are related to those issues. So the table within that document is non-standard as well, and it's typically embedded within a body of text. But it does have a fixed set of columnar elements where we'd know the table if we saw it, just based on some of the elements that it contains. And also another aspect of it is, given the financial nature of the tabular component of these documents, it's actually a really a focal point of our work. So one of the things is, well, how do we identify the table across multiple different file formats, and when the table is going to be embedded within text, in a multi-page document. So again, a lot of our work is focused on reducing the level of manual effort that needs to be taken on to achieve some type of task. So if somebody had to identify, transcribe, and standardize these tables across a large set of documents, that would be a highly manual process. So one of the things that we wanted to see is, well, could we develop a model using deep learning architectures like those in object detection to see if we can create and train a table detection model. So what we were able to do was to use deep learning to train a model capable of detecting these tables. In particular, we used faster region-based convolutional neural network, or FRCNN, and that is a region proposal deep learning architecture where the feature maps from convolutional neural network are jointly trained with the region proposal network. And what it looks to do is it'll look at an image and determine whether or not the image that it's been trained to detect is present and where within that image the object might be. So in appeals, we actually didn't have a sufficient amount of data to train a deep learning model. However, there exists image classification models in the open domain, and we were able to use transfer learning to tailor a model that can detect tables using only a fraction of our data, so only 200 cases. So one of the things that we wanted to check for is to make sure that our results and our successes of this model would translate on all document populations. So one of the things that we tried to do was, and you can notice at the top left of the slide, is to transform the image to better highlight the tabular structures. And after we did that, what we did was then retrain the model on publicly available images that contain tables. And this allows us to create a table detection, table identification baseline. Then after that training on publicly available images that contain tables, we retrained the model a second time, this time using our images from the appeals process in an effort to increase accuracy for the population that we were working with. So this was, a really, novel piece of work, and we'll continue to explore work in this space. So on to another use case, sort of in the document and the image processing spaces. We've used computer vision and template matching to find the location of a predetermined template within a larger image. So in our particular use case, we wanted to find the particular section of a tax form. So if you take the tax form itself as an entire image, then we could create a template of the section that we're interested in and use computer vision to basically scan over the document and try to extract the sub image that we're interested in. Because we're also interested in not only the sub image, we're also interested in some of the data that's within that sub image. We take the image, the sub image that we found, and perform optical character recognition, or OCR, on it to try to extract out the information. So for our particular use case, we actually had tax exempt and government entities interested in estimating potential refunds for their taxpayers and for their customers rather. So we had to, through a large collection of documents, find a page that we're interested in, run the template matching on that page, and find the sub image, and then OCR the image, and then take that data and put it into a standardized format so it can be analyzed a little bit further. So, speaking of trying to identify and find a page that you're interested in, we often have times where taxpayers are going to submit a form to the IRS, and that form by itself only has 1 or 2 pages, but the submission is also going to contain additional support and documentation attached with the pages. So these attachments really introduce a lot of additional data that we're not really interested in. So the challenge is that our customers face is, well, how do I get at the data that I'm actually interested in? Again, the challenge is when you have tens of thousands or hundreds of thousands of these submissions, then that leads to hundreds of thousands of pages. In some cases, you might get in excess of 1 million pages, and manually going through those these types of submissions and that level of pages is definitely impractical. So one of the things that we started, one of the things that we developed is a process where we OCR all of the pages of the submission, and we convert the raw text into a term document matrix. We also OCR the blank pages of the form. That way we can use that information to put the rest of the text into some type of context. So one of the things that we're able to do is using latent semantic analysis and singular value decomposition is to see how the text for all pages relate to one another. So this is just like comparing documents with one another, and we use cosine similarity to do this. So we also have, again, as I mentioned, we had the blank pages of the IRS form, and the reason that we include those into our term document matrix is that the thinking is that a blank IRS form is going to have a lot of similarity to a completed IRS form. So outside of just the taxpayers information being in there, everything else within the form is identical. So what we're able to do is use cosine similarity, compare all of the pages to the vectorized text of the blank pages, and we're able to create flags of whether or not we think a specific body of text is actually the form that we're interested in. So if you look at the image with the dots, the scatter plot, and you see the orange square and the green square, that's a situation where we have page 1 and page 2 of a document being represented by those squares, and everything that clusters around it are things that we flag as being page 1. And the same thing goes at the bottom of the page, where we flag documents that are clustered around that green square as being page 2, and everything else is the attachment data that I mentioned earlier. That's just noise, being included with the submission. So simulation. As I mentioned at the beginning, and maybe a time or two, during the tutorial, I'm responsible for the enforcement revenue information system, the system that tracks revenues at the taxpayer level across IRS enforcement activities. And I also mentioned that tax administration is, has some interconnected and interdependent components, and IRS enforcement is definitely representative of that. So I mentioned a scenario where, a tax administrator may have a potential reporting compliance issue with a taxpayer, and they want the taxpayer to provide some additional documentation to substantiate what they reported. So if we continue that scenario, let's say that the taxpayer is unable to substantiate what was reported, and this changes their underlying original tax liability, and this means that they're going to owe additional taxes plus any additional penalties and interest. So now this taxpayer who had a reporting compliance issue, now they owe money, and if they can't pay by a specified time period, then their account will enter the accounts receivable inventory, and now the IRS can move to collect that balance. So now you had something that was a reporting compliance case that is now morphed into a payment compliance case. So from a functional perspective, the resources that we use to pursue reporting compliance are not necessarily the same resources that we use to pursue payment compliance issues. So now you have a situation where the reporting compliance function can actually generate a subset of the inventory for the payment compliance function. So that's just one example of some of the types of interactions that we can see occurring within IRS enforcement, and that's just. But you can also have a situation where, let's just say the taxpayer started in reporting compliance, but they were successful in substantiating their claim. So in that scenario, you have a situation where enforcement starts and stops within that reporting compliance function. Taxpayers could also start in the reporting compliance function. They can fail to substantiate their claim, just like we did in the original example. But let's say they appeal the decision, but after appeal, they're found still owe tax. So that's a situation where taxpayer moved from reporting compliance to the appeals process to payment compliance. So a lot of different interactions, a lot of different opportunities, but it's a situation where because of the available data that we have on enforcement activity, so we know the type of case, the dates that enforcement activity started and stopped within a particular function. We also would know some of the enforcement results, such as whether or not additional tax is going to be owed, how much of that tax is going to be paid, and when that tax is going to be paid. And we can also layer in some of the resource capacity information from different enforcement functions. So with that, we felt like it's a really strong opportunity to develop a discrete event simulation model that can help us understand what drives enforcement revenue results. So whether it's taxpayer behavior, different taxpayers having different outcomes on their cases or resource issues, we can develop a simulation model capable of doing scenario testing to help us understand impacts that operational changes have on enforcement revenue. So one scenario could be, let's say we're unable to work a certain type of reporting compliance case. How does that impact downstream operations, and how does that impact enforcement revenues? Another scenario could be, let's say we were able to receive additional resource capacity within a payment compliance function. How does that impact utilization rate for that payment compliance function? Because again, the payment compliance function is not necessarily in charge of creating all of this inventory that can come from other parts of the process. So, how does that additional boost in resources impact utilization rate? Or how does that impact enforcement revenues? So, one of the things I think I tried to mention at the outset was we have a lot of taxpayers and we have limited resources. And in many cases, these resources are diminishing over time. So, from my perspective, I think there are a lot of different opportunities to explore constrained optimization problems within the IRS. So one example of that is, let's just say you're looking to find where do you need to place your next IRS office. So you have additional real estate budget and you want to figure out where to place the next IRS office to maximize geographical coverage. So that lends itself to being a constrained optimization problem. And we have teams working on that very problem. And you also, a related issue is if we do have, taxpayers who have to interact with IRS personnel. So if you're gonna hire additional staff, where do you put that? Where do you hire that staff so that they're able to interact with taxpayers in such a way that it minimizes travel costs, to the service and the taxpayers. Another situation is, you know, and it's somewhat related to the simulation example that I just mentioned, is if you're given a set of enforcement resources, how do you deploy those resources for maximum benefit? So, you know, again, a lot of different opportunities in the constrained optimization space. But again, the challenge there is that things tend to be, you know, really dynamic. So, you know, really it's hard to make it a deterministic problem. So, you know, really how to do that under uncertainty is really the largest challenge. So earlier, I also mentioned that there are different ways by which the IRS can associate taxpayers with one another. And I mentioned that taxpayers may share the same tax preparer. So that represents one of those associations. But knowing which preparer prepared which set of returns, that's important for the IRS to know. And sometimes this prepared information might not be accurate. And this can be done either intentionally or inadvertently. But a lot of manual effort would be required to identify prepared mismatches, coming through a lot of different data sources and trying to validate prepared information. But we had the ability and available data, and we can use text and graph analytics to assist with reducing the level of manual effort required. So again, a situation where, you know, humans going to be in the loop, but we're looking, you know, looking to analytics to see if there exists opportunities to make, you know, help make the process and help make the human operation a little more efficient. So in this particular case, you know, we're able to, you know, reduce that manual review by over 50%. So again, this is not only an efficiency case, but with that 50% of additional resources getting freed up by, you know, what the analytics was able to provide from an efficiency standpoint, you now can redeploy those, you know, additional resources to do other things. So identifying something that's, you know, the next best thing that's of highest value, that's sort of the next step after, you know, you're able to identify some of these efficiency gains. So this concludes my tutorial. Thank you to the session chairs for the opportunity to present. Thank you to the attendees for your participation. Hopefully, you know, you now see, you know, the wide range of opportunities that exist in, you know, for analytics to help make tax administration more efficient and more effective. So, you know, thank you again for everybody's time.